Hello, everybody. We're on week 3 of digital learning and we are finishing up our transformation chapter. So, we're doing something a little bit unique because we are 1 week out from spring break. And I know y'all don't want to start another chapter before spring break because then we'd have to spend just as much time reviewing after spring break. So, we're kind of going to do a week long assessment. And this will be due Friday at midnight. So, your task, instead of taking a Google Form test, which we all know we have our notes out and we're completing the problems with our little cheat sheets, which, hey, fine by me. I did that when I was in college, when I was on online classes. So, we're doing something a little bit different that'll be beneficial to all of us. You are going to be creating a review book of all the components of transformations. You're going to practice graphing all of these transformations, and this may be a review book that you can use on a future big assessment at the end of the school year. Oh, wow. Okay, so for today's agenda video, I'm going to walk through all of the project components, little bit of tips and tricks of how to complete the project, where stuff's located for the project. And if you have any questions while I'm going through it, write them down, shoot me an email, and I'm more than happy to answer those. All right, so this project is posted on Google Classroom. Voila! I mean, it's a light gray right now because I haven't posted it, but it will be posted. Yours will be a dark gray. You'll have your agenda video, which you'll start out at, and then you'll have your review book. If you open your assignment, you'll have two things. One will be a Google Doc, another one will be a Google Slides. The Google Doc is the project instructions. The Google Slides is a format or template that you can use, and we'll get a little bit more to that. So let's start at the top of the instructions. So today you'll be creating your own review book for this unit's material. The review book will be created digitally in Google Slides and submitted through Google Classroom. So you will not be submitting anything from the Google Doc. It will all be in the slides presentation. The review book will highlight each section in the transformations chapters. So rigid motion, translation, reflection, rotation, dilation, and line of symmetry. I will not be assessing you on vectors. You can design the review book how you like. However, the review book must include the information below. The review book must be easily readable, okay, and neat. I gotta be able to read it. You can, whatever creative stuff you want to throw on there, just make sure I can understand the information. At a minimum, your review book should have 7 slides. The right column indicates the required information that should be present on each page. That's talking about the table. So let's see. Let's add this. In the table below, the right column indicates the required information that should be present on the page. You may add additional slides if necessary to fit all the information. If you add extra slides, make sure you include a title on the slide. So your review book is essentially going to be a Google Slides presentation. Each slide I look at, it's like a new page of my review book. It's going to be like one massive book cheat sheet. And I tell you exactly what information should be on there. So your first slide should be a title page. On my title page, I should see Transformations Review Book. I should see your name, and I should see your class hour. So I want to take this moment to pause. Okay, the Google Slides presentation I have uploaded. Okay, that is a template I have made to kind of give you an insight of what I am looking for. Do you have to use this template? No. You can create your own, give it whatever background you want, whatever suits your fancy. However, this is just one that I've already made to give you kind of like an image of what it should look like. All right. My next slide is my transformation slide. On that slide, I will include the slide title, transformation definition, what is a transformation? If I have a transformation, what changes are happening? So identify what changes are in transformations. You'll have a definition for rigid motion. You'll identify an additional name for rigid motion, and you're going to identify the congruent properties and the types of rigid motions. Now, You notice how on my template, I have the same exact information over here. I do not want you to type in definition. I want you to give me the definition for transformation. So I just typed it in there to show you kind of like an idea what I want it to look like. Just a bullet point list works perfectly. But I want you to find that information and put it in there. All right, for translation, you should have a slide title. You should have a definition. You should tell me what coordinate notation is. You're going to identify, okay, what is H and K and what do they mean? And then you are going to have an example. Now, for the examples, in the template, I've copy and pasted a graph from Google Images, and I just pasted it in here. So when you have a graph, you should have a graph title, okay, the pre-image coordinates and the image coordinates. And we'll get into, I believe on the next slide, I'll show you what that looks like. For my reflection, I'll have a slide title, I'll have a definition, and you are going to show 3 examples for reflection. So my example right here is I have the reflection in the x-axis. You get a pick. You get a pick if you want a reflection across the x-axis or the y-axis. I use shapes in Google Slides to add my shape here, and I have my points. I have my pre-image coordinates and my image coordinates. I also indicate what those are to the left-hand side. So I need to be able to see, I need you to be able to identify what those coordinates are. You can copy the same fashion, same format that I have done, or you can come up with your own. Just make sure that information is displayed. So you'll have a graph for the reflection on the x-axis or y-axis, you pick. You'll have a reflection in across a horizontal or vertical line that's not the axis. And then you'll have a reflection in the across a line of y equals x or y equals negative x. One thing I want to note with those, this is a great example of how if I had I don't have enough space on one slide, I can add an additional slide. That's going to be your part 2. So just add an extra slide and relabel it and add those graphs. You can use as many slides as you want. You should just have a minimum of 7. All right, rotation. You are going to have your slide title, definition. You're going to tell me what are my rules for rotating counterclockwise at 90 degrees, 180 degrees, and 270 degrees. You're going to tell me what is the process for clockwise rotations, and then you're going to give me 3 examples. So one for 90 degrees counterclockwise, one for 180 counterclockwise, and one for 270 counterclockwise. You'll have a slide for dilation, you'll have your title, and then you're going to have a definition for your dilation. You'll identify what are my congruent and similar properties, identify why dilation is not a rigid motion, identify how to determine if a dilation is an enlargement or reduction. You're going to provide me with my dilation rule, and then you'll have 2 examples, one for an enlargement example and one for a reduction. Okay? Then your final slide will be your line of symmetry. You'll have your slide title. You'll tell me what are my 3 types of symmetry, and then you'll give me 3 examples. So you will put in 3 examples. One, you don't have to have an example like, okay, this example is only line symmetry, this example is only point, this example is only rotational. I just want to see all 3 types. So whether it means one example only has one and the other one has all 3, I just want 3 examples that demonstrate all of the types. All the types are demonstrated once, if that makes sense. Okay. So in your 3 examples, you've demonstrated all types of symmetry. And those are your slides. A couple other stipulations. When you are graphing, you may use any method or application to represent the transformations in your review book. For each type of transformation, you must graph a polygon. So for example, in my example up here, reflection, okay, I have 4 points. That's a polygon. It's not just one. So you're not reflecting only 1 point. You have to have a polygon that has at least 3 points. Each point must be labeled accurately and use the required notation. Another thing I want to note, you have to come up with a new example for reflection. You cannot just copy my example. If you copy my example, I'm going to give you 0 points for that one. I just added that on there to show you exactly what it could look like. When I've graphed, I just copied and pasted from Google Images. But if you want to use another application, you're more than welcome to. This is just one method of how to complete this task. Your template, this template you are more than welcome to use, but you may create your own. Just make sure everything is legible and neat. If you have any questions on the project, please let me know. I am here to assist. And it's going to be due Friday. So this is your assignment for the whole week. Since you have a whole week, do not complete it in one day and give me crap. Okay, I have high expectations for this assignment. It's going to be in detail. Your graphs are going to be amazing. It's going to have all the requirements. Use the tables I provided to you as a checklist to make sure you have all the information. I have a rubric down here at the bottom, which basically re-enhances all that information I have listed up here. Okay, so make sure you clearly read the directions. When you think you're done, double check. Use it as a checklist. Make sure you have all the components. And as always, email me if you have any questions. All right, guys, have a good day. I don't know how to end a screen record. Oh, there we go. Okay, bye, guys.